Next problem, find all the local maxima, local minima and saddle points of fxy is equal to x cube plus y cube plus 3x square minus 3y square minus 8. Okay. So first of all, write the given function f of x comma y is equal to x cube plus y cube plus 3x square minus 3y square minus 8. Okay. So first of all, find fx. Fx represents dou f by dou x. That means we have to differentiate the function f with respect to x partially. Okay. So derivative of x cube is 3x square. Derivative of y cube. So with respect to x in partial derivative, y cube is completely constant. So its derivative is 0. Derivative of 3x square. So 3 into derivative of x square. Derivative of x square means 2x. So 3 into 2x, which gives 6x. So with respect to x, 3y square is completely constant and 8 is also constant. So their derivatives are 0. Therefore fx is equal to 3x square plus 6x. Next, we have to find second derivative, second partial derivative. That means dou square f by dou x square. That means again we have to differentiate dou f by dou x with respect to x. Okay. So 3 into derivative of x square gives 2x, 3 2 is 6x. 6 into derivative of x means 1. So 6 1 is 6. So this is fxx. Okay. Next, fy. Fy means dou f by dou y. Okay. That means we have to differentiate this function with respect to y partially. Okay. So with respect to y, x cube is constant. So its derivative is 0. Derivative of y cube with respect to y, 3y square. So with respect to y, 3x square is constant. So its derivative is 0. And derivative of 3y square. 3 into derivative of y square. Derivative of y square means 2y. 3 2 is 6y. And derivative of 8 is 0. With respect to y, 8 is constant. Okay. Next we have to find fyy. That means dou square f by dou y square. We have to differentiate dou f by dou y again with respect to y. So that is fyy. So derivative of 3y square. 3 into derivative of y square. Derivative of y square means 2y. 3 2 is 6y. And derivative of minus 6y. So minus 6 into derivative of y. Derivative of y is 1. So minus 6 into 1, minus 6. Okay. Next we have to find fxy, which represents like this. Dou y of dou f by dou x. Okay, fxy means it is like this. Dou y of dou f by dou x. That means we have to differentiate fx with respect to y. Okay. So since fx it is completely x function, there is no y term. So 3x square plus 6x. So it is completely depending on x. So with respect to y, these derivatives are equal to 0. So therefore fxy is equal to 0. Okay. So for maxima or minima, we take the first derivatives are equal to 0. We have to find the local maxima and local minima and saddle points. For that purpose, we take fx is equal to 0 and fy is equal to 0. So let us see that. For maxima or minima, fx is equal to 0. We take fx is equal to 0 and fy is also 0. What is fx? 3x square plus 6x. Okay. 3x square plus 6x is equal to 0. Take 3x as common, we get x plus 2 is equal to 0. So 3 goes to 0, we have x is equal to 0 and x is equal to minus 2. Again we take fy is equal to 0, which implies 3y square minus 6y is equal to 0. So fy 3y square minus 6y. So take 3y as common, we get y minus 2 is equal to 0. So we have y is equal to 0 and y is equal to 2. Okay. Therefore, we have the points like this. X is equal to 0, y is equal to 0. This is one point 0 comma 0. Let us say this is A. Okay. Second one B, x0, y2. 0 comma 2. Next C, x is equal to minus 2, y is equal to 0. Minus 2 comma 0. Next D, x is equal to minus 2, y is equal to 2. Okay. So these are the points which we have to check whether the function is local maxima or local minima. Okay. Let us see continuation. Okay, continuation. So we have the information like this: a is equal to 0, 0, b is equal to 0, 2, c is equal to minus 2 comma 0, d is equal to minus 2 comma 2, fxx is equal to 6x plus 6, fyy is like this 6y minus 6, and fxy is equal to 0. Okay. Next we have to find the discriminant. The formula is fxx into fyy minus fxy whole square. Okay. So this is called discriminant. fxx means 6x plus 6 is multiplied by fyy 6y minus 6. fxy is 0. So 0 square is also 0. So take 6 as common in both the brackets. So 6 into 6 we have 36. The remaining are x plus 1 into y minus 1. Okay. So next we have to check the points one by one. So at a 0 comma 0. So first of all we have to check the discriminant. Okay. D is equal to, at 0 comma 0, D is equal to 36 into x means x is equal to 0, y is equal to 0, 0 plus 1, 1, 0 minus 1, minus 1. So minus 36. That means it is less than 0. If discriminant is less than 0, then the point is said to be saddle point. Okay. Therefore, if discriminant is less than 0, the point A00 is said to be saddle point. Therefore, 0 comma 0 is saddle point. Okay. Next we have to check at the point B0 comma 2. Let us see here. B at B0 comma 2. So first of all we have to find the value of D discriminant. Discriminant is like this: 36 into x plus 1 into y minus 1. So 36 into x plus 1. So x means 0, x plus 1 means 0 plus 1, 1. Y minus 1, y minus 1 means 2 minus 1, which gives 1. So 36 into 1. So 36, which is greater than 0. Okay. Next we have to find fxx. fxx means 6x plus 6. So substitute this point in this. 6 into x means 0. So 6 into 0 plus 6. So totally this is equal to 6, which is greater than 0. Okay. Therefore, if discriminant is greater than 0 and fxx is greater than 0, then this point is said to be local. Then the function has local minima at this point. Okay. Therefore, B0 comma 2 is called point of local minima. That means at this point the function has local minima. So this is point of local minima. Next we have to check the value at the point C, minus 2 comma 0. So at this point, first of all we have to verify D, discriminant 36 into x plus 1 into y minus 1. X means minus 2 here, minus 2 plus 1, that means minus 1. Minus 1 into y minus 1, that means 0 minus 1. Here y is 0. 0 minus 1 gives minus 1. So 36 into minus 1 which is equal to plus 36 which is greater than 0. Again we have to check fxx. What is fxx? 6x plus 6. So 6 into x means minus 2 plus 6. So minus 12 plus 6 which is equal to minus 6 less than 0. Okay. If discriminant is greater than 0 and fxx is less than 0, then the function has local maxima at this point. Okay. Therefore, C minus 2 comma 0 is called point of local maxima. Okay. If discriminant is greater than 0 and fxx is greater than 0, then the function has local minima and the point is said to be local minimum point. If discriminant is greater than 0 and fxx is less than 0, then the function has local maxima and the point is said to be point of local maxima. Okay. Next we have to find the D. Okay, let us take the point D, minus 2 comma 2. At D, minus 2 comma 2. So first of all we have to check the discriminant 36 into x plus 1, that means minus 2 plus 1 which is equal to minus 1, y minus 1, that means 2 minus 1 which is equal to 1. So 36 into minus 1 which gives minus 36, that means less than 0. If discriminant is less than 0, then the point is called saddle point. Therefore, minus 2 comma 2 is called saddle point. Okay. Therefore, finally, 0 comma 0 and minus 2 comma 2 are saddle points. Okay. 0 comma 2 is point of local minima and minus 2 comma 0 is point of local maxima. Okay. So this is the problem. Thank you.